Hi and welcome to Jawad's Academy. Today's lesson is about simplifying rational function. Before we do any example, I just want you to understand that we must follow a few steps in order to simplify. The very first step is factoring, making sure that everything is in multiplication form. The second step is stating any restrictions for the variable that are located at the bottom of a rational function, because we do not want to have 0 in the bottom of any rational function. Then last would be your third step, simplifying. Simplifying top to bottom, left to right, one piece at a time. And here's an example of a rational function in terms of monomials over monomials. Then we're going to do polynomials over polynomials. So in case, for example, we have example number 1, 6m to the 2 n to the 4 over 18m to the power of 3 and n to the power of 2. So in this case, we do not need to factor anything because since we're dealing with monomials, we're just going to go ahead and state the restrictions for the bottom of this rational function. Then we're going to simplify. Restrictions for the variables only for the bottom of this rational function, which is m and n. Since it's monomial, automatically your restrictions are m cannot be 0 and n cannot be 0, because if I were to substitute for m 0, the whole bottom will go to 0, or if I were to substitute for n 0, the whole bottom will equal to 0. So we cannot let m or n be 0. That is the restrictions. Now we're going to simplify left to right, top to bottom. So we start with the coefficients first. So I see that 6 and 18 can be reduced once, and 3 times 6 goes to 18. So we have 1 over 3 in the bottom. So this is what we have so far. And then we're going to look at the variables. So m to the power of 2 here on top, m to the power of 3 in the bottom, meaning that we have 2m on top of this rational function and 3 in the bottom. So that 2 cancels. We only left with 1m in the bottom, so we just leave it there, right in front of after 3. Now we have, in terms of n, we look at the n's. Now we have 4 on top and 2 in the bottom. So of course, the top wins by 2. You can look at it that way, a lot easier. Now this is in simplest form of this rational function. So what we're doing with simplifying, we're not again adding or subtracting or doing anything to add or subtract the value of this rational function. So if you were to substitute for n any value and for m any value in here, you will get the exact same answer if you were to substitute the same value in here. So we're just rewriting it in simplest form. For example, here, very simple example. If I have 4 over 8, which is the same as 1 over 2. So there is no difference in terms of the value between these two. But this is in more simplest form than this. So that's exactly what simplifying rational expression represents. Now let's do another example where we got to do polynomials over polynomials. So I'm going to push this forward in order to get more room for ourselves here. So here's the example number 2. So we have x squared plus 3x minus 18 over 9 minus x squared. So the very first step of simplifying rational expression is to factor the top and factor the bottom. So we're going to do that. The top is simple trinomial factoring. So we open 2 pair of brackets. We throw x and x. The product is negative 18 and sum is 3. We know that plus 6 and minus 3 will work. And the bottom is difference of square factoring. So both bracket carries exactly the same thing, except the signs will be different, and they both are square rootable. So square root of 9 is 3, and 3 square root of x squared is x and x. And this is how we factor these quadratic relations. So if you still have questions or concern about factoring, I already done videos about all types of factoring. Please go ahead and watch that, because it makes life a lot easier when you're dealing with simplifying rational expression or rational functions. So now we have it in factored form. So before we simplify top to bottom, we must state the restrictions. And the restrictions in this case, since it's binomial, it's the zeros of the bottom. If the zeros of 3 plus x is minus 3. If I were to substitute for x minus 3, the bottom will go to 0. So I should say x cannot be negative 3. Now in this case, the second bracket, if I were to substitute for x3, 3 minus 3 will equal to 0. So the whole thing will go to 0. So x also cannot be 3. So x cannot be plus or minus 3. That is your restrictions for the bottom. Only stating for the bottom, not for the top of a rational function. It's okay to have 0 on top, but it's not okay to have 0 in the bottom of a rational function. That's the reason we're stating restrictions. Now we can simplify. X plus 6, there is no identical exactly like this term x plus 6 in the bottom, so we cannot simplify x plus 6, so we leave it as is. Now, do we have x minus 3 in the bottom? Not exactly, but we have x minus 3 and 3 minus x can be reduced if you were to put a negative 1 in the very front, because these go at each other and the answer would be negative 1. And I'll show you why when you were to simplify these two as equal to negative 1. So let me finish this first. Now we only left with 3 plus x, and the bottom would be 3 plus x. Now this is in simplest form. Now I'm going to go back and show you why when you were to reduce x minus 3 and 3 minus x, the answer would be negative 1, not positive 1. And I'll show you right here. I'm going to push this up a little bit because I like to show everything with the reason why we're doing this, because once you understand the reason, life would be easy and you'll enjoy learning, not just memorizing math. So for example, I had here x minus 3 over 3 minus x. We were said to cancel this, you will have negative 1. Let's substitute for top and bottom for x 2. And this way we can prove why the answer is negative 1. So if I were to substitute for x2 here and 2, and I should get negative 1. So I have 2 minus 3, and I'll substitute for x here too. I have 3 minus 2. So 2 minus 3 is negative 1, and 3 minus 2 is positive 1, and negative over positive would be negative, so the answer is negative 1. And now we know why x minus 3 can be reduced by 3 minus x, but we got to put negative 1 because in very front of this rational function in simplest form. So the answer of this, when we were to cancel, the answer would be negative 1. So and that's the reason why. All right, I hope this lesson was very useful for yourself, and hope you learn. But please practice a few times these examples, and then you can apply to your textbook questions or different examples from your textbook, and I'm sure you're going to do well. So please do not forget to subscribe, and if you have any concern or question, you can leave your questions below in comment box and I should be able to answer. Till then, wish you all the best and good luck.